Sure, thank you. So welcome everyone. This talk is a 40 minutes talk, so I'm going to try to make it exciting. We're going to talk about like oracles in general, not anything about like just price oracles or other things, which we'll get into. Before that, just a bit about myself. I'm a security engineer and smart contract auditor with Consensus Diligence. In a parallel life, I'm doing my PhD right now at Concordia University. My thesis is mostly on new technology or old crimes, how crimes are using blockchains and cryptocurrencies to evolve into new forms. And we can read more about these at my website. Previously, I was working at a startup which were making these Bitcoin ATMs. If you have seen this orange interface, probably you've seen some of my code out there. And it was a really interesting experience. And from that company, that triangle that you see up there kind of evolved, which was another project, which I'm going to start talking about that and lead to the actual Oracle talk. So back in those days, I just want to like talk about, before getting to oracles, talk about one of the experiences I had in real life, and mainly to say that I believe rethinking the way we are doing oracles on DeFi and other blockchain space is really important aspect, and we should make sure as a whole ecosystem we talk about it more often. So it was 2016. My boss came back to me and he was like, there's this thing called Ethereum. Do you know about it? And I was the only blockchain engineer in the whole company. And I was saying, yeah, I've read about this one. And they were like having this idea of having a decentralized derivative market on blockchain, which then was Ethereum. And me being this naive Bitcoin only blockchain developer, I was like, cool, just give me 2 days. I'll learn smart contracts and make a simple application to store the price from an exchange API, just simple as that. And I was mostly working with Python back then on clouds. So in Python, it's just 2 lines. You import the library, you read. My idea of writing a Solidity was really similar. It's like, I just need to get an API. And just to give you some context, this is before even Pragma was a thing for Solidity. And I think the last update on my code was 0.4.1, the compiler, so it's pretty old. So I was like trying to figure out how to write this. And after a day, I was like, wait, who's calling this API? Like everyone's calling this API at the same time. Who's storing it? What's happening? And that's when I realized, oh, wow, like this Ethereum and smart contract is much bigger than I thought, similar to cloud. So let's just give you some context on like what we were trying to build. So we were trying to build this decentralized derivative market. And so basically we need a smart contract for the code logic that holds the funds. We needed a price feed, and for proof of concept, we just wanted Ethereum to Bitcoin price. And more context, there was no stable coins yet then. Tether became a stablecoin on Ethereum in September 2017. MakerDAO white paper came out in December 2017, so a year and so after all these. And we needed like a UI and users. So for makers, we just brought in users. For taker, we were using the smart contract as taker. I'm not sure how many of you have been around back then, but there was this project by around DevCon 3 called Prism by Shapeshift, which was a similar idea. And if you think, because AMMs, automated market makers, were not also a thing, and I don't remember reading about bonding curves back then. So like if you see this as Uniswap, which is a 2-pair, Prism by Shapeshift was like a balancer, so you could have like a basket of things. So I don't want to get into details of this, but it was a colored option contract, meaning that you could go long or short, and you would profit from that up to double your amount. So just a simple logic in the contract. And we wanted this price feed. So what options we had? So only a few projects existed back then, and it was a lot of them were buggy. So we had this smartcontract.com, which now is known as Chainlink. So back then they had this price feed and was only updated at 12 a.m. midnight once a day. So it was not really what we wanted to go for. We wanted to go for an optional time a day. So you could choose any expiry date and your price and just buy the option for that. There was this other project called Oracleize It, now is known as Provable Things, and it was more of a request response to fetch any API, and this was more of what I was looking for. So just to give you an idea how Oracleize It worked, so on the bottom side, you see the Oracleize It server. So this server, and they had this smart contract on top on the blockchain. So your smart contract would send a request as a transaction to Oracleize It smart contract. Oracleize It server was monitoring this smart contract for events, and when a request comes, it would fetch the API using a server, send it back to this Oracleize It smart contract, and then send it as a transaction to your contract, so a callback. So I remember I implemented this whole thing. It seemed to be working, and Ethereum was cheap, so we were just using mainnet to test, which was okay. And one of the last interactions I had with Oracleize It, I'm not saying bad things about them, just saying implementation in 2016. So it was a Friday afternoon. I was like trying to open some options and try to wait for them to settle. And I waited for hours and nothing happened. I tried to debug everything. I stayed overnight. It didn't work. So I was like, okay, I don't know. I just emailed Oracleize It support describing the problem. I was like, I have this problem. What can I do? And on Monday morning, when I came back to work, I saw that all the callback transactions were in, all the options were settled. And I got an email from Oracleize It support saying that, oh, there was an issue with the server. It should be working now. Don't worry. And in my mind, it was like it took 2 days to settle. Like, this is not acceptable. I need my own price feed. So that was the motivation of creating this project called PriceGeth, which this is again back in 2016, which was really similar to how Oracleize It worked, but it was a price feed. So there was this component called price fetcher, which was basically storing the price every second. It was monitoring Geth for new blocks, and whenever a block came, so it would just send the price at block time with block number as the index to the blockchain, so to the smart contract. And so eventually we would have this price Geth, which is a price feed smart contract, and also a historical price ledger for anyone to read. So if this architecture is like familiar to you, probably you know about Time Crier, which uses SGX to make this more secure, or one of the more recent oracles called Dia, I think, which is pretty close to the same design. So this was the interface. We created this interface that, as you can kind of see, it's a bit more convoluted. The price feed was following the actual price, so everything was working. We were like, so what now? Should we do an ACO? Like, what's going on? But we had some trust issues, so we were like, we don't want to be trusted in the system. And in late 2016, basically, like, we shut down the project, even though everything worked for proof of concept. PriceGeth was okay for proof of concept, but we wanted a decentralized system. We didn't want to be trusted, to have the risk of liquidity providers being exploited for any reason. And it was centralized. Like, we were running the price feed, and that was not really accessible to us. And this is actually an article from News BTC, and this last sentence is from that article saying, it is too early for financial derivatives in the Ethereum ecosystem. It seems technological restrictions are to blame in this regard. Overall, it was a fascinating experience. So as I put my academic hat on and wrote this whole experience as a paper, which was published at Financial Cryptography in Malta, I suggest you, if you're trying to design a system, read this. Some parts might be a bit outdated, but overall, it's still like a really good read. And you may know one of the co-authors as Meta Coven, or the owner of Beeple 5000 Days, good old times. And for the logs, like this paper is also available as an NFT. I don't own it anymore. Someone bought it from me, but if you want to poke around, it's on Zora and the link is at the bottom. You can check it out. So this was the story I want to tell you, to like what I went through early on with oracles. And 5 years later, we are here. Oh, actually, yeah, 5.5 years later, because I also did my comprehensive exam of PhD on oracles. Mainly, like the title was Oracles. Without them, smart contracts are lost. And it was mainly focused on the academic work in oracles. So looking at projects like Time Crier, Deco, Australia, and I really tried, and I fit in Chainlink in there. Chainlink wasn't really an academic paper, but it was popular enough to be included. So now we, like, this whole talk is surrounding this paper, which we released recently, and it's under review. But it's a SOK paper. If you know SOK, if you don't know SOKs, it's a systemization of knowledge, meaning that it's a comprehensive research on the state of oracles. So everything about oracles that we know in a systemized way. And we came up with this modular framework to be able to analyze oracles, think about oracles, and systemize the design alternatives. And we talk about like a lot of attacks in the paper, some mitigation strategies, and mainly how to rethink oracle design. And the paper is available online if you want to read. So back to the subject, oracles. Let's just define this. What is an oracle? What is the context? And what are we doing here? So we define oracles as an oracle is a bridge or a gateway that connects the off-chain real-world knowledge to on-chain blockchain network. So just this connection on the bridge is an oracle. We do not limit this definition to price discoveries, which is the most recent narrative about oracles in the context of DeFi. We just talk about oracles in general. And the oracle problem, which is if the oracle is trusted, why not just give all the calculation and computation to the oracle? And how to solve this oracle problem is still real, still an open problem, but I believe we are really close to a solution. We'll see. We're pretty close. So the prophecy of decentralization, as Morpheus once said, the prophecy will be fulfilled soon, but before it can be, the oracle must be consulted. Based on this research, like, we learned interesting things. That a natural question that a smart contract developer should ask is, if I'm trusting the oracle, why not just have it compute everything? And a lot of these oracles that we looked at, there's a deep centralized point somewhere in there, like almost all of them, but we'll get to those points later on. As I said, like, oracles mostly nowadays are used for price discoveries, which include the stable coins, synthetic assets, derivatives, even some prediction markets use that, and also the dexes. But there's so much more that oracles can do. Like, as an example, for provenance systems, like for supply chain, to identify where an item is, or for identity, a government or an institute can run its own oracle to do KYC, do some kind of like identity on the blockchain. As you may know, blockchains are deterministic, so no randomness. So for randomness, we have projects like Chainlink VRF, verifiable random functions that offer this service. Some less explored places like dynamic NFTs, a most famous example, which is on the, like, I think it's on the Chainlink blog, is about, like, if you have these NFTs of a soccer players, they could change based on how that player is doing in real life. So these are all use cases of oracles that are out there, and there are so much more. So basically here we came up with this modular workflow. We break down the Oracle system and design into modules. And just a disclaimer for the audience, if you've never thought about creating or understanding or even analyzing an Oracle system, the next few slides might seem kind of irrelevant to you, but toward the end, it will all come together and give you an idea on how to think about internals of an Oracle. This is more systemizing and rethinking Oracle design. So these modules that I'm getting into could be on-chain, off-chain, in different orders, but all oracles, even the future oracles, we should be able to define them using these modules and this framework that's in this paper. So there are these main six modules here, are the core parts of like the Oracle design, but also consider that we have to get that data to a smart contract. So there's a whole part of interacting with blockchain. And as we get later in this talk, there are so many parts that, depending on the design you have, some aspects of how the blockchain works can have impact on that. And you probably need to redesign some parts to make sure you're not vulnerable to those kind of attacks. So let's get into this. So the first thing is ground truth. Like any Oracle designer should ask this philosophical millennial-old question that what is truth? Or as some know, truth with capital T. So is this like objective, subjective? Like as an example, if I ask all of you here, what is the real price of Ethereum to you now? Probably you're going to have some numbers that deviate from each other. It's not going to be exact same number. And so basically we're trying to solve here that what is the best way to collect raw data from sources and aggregate them to have reasonable data quality. So the next step would be data sources, like these passive entities that store, measure the representation of ground truth. And we have these common types like database or APIs, similar to centralized exchange prices. We have sensors, which could be used for blockchain supply chain, humans for prediction markets. Some oracles use like human judgment. Smart contracts, which are on-chain markets, such as Uniswap being used as Oracle, or a combination of them, or it can be like two smart contracts, like two different combinations. We have really interesting details and attacks about these in the paper, but I don't think we have enough time to go through them. So the next one is data feeders. So basically these entities who gather and report data from the source to the Oracle system. So a common configuration would be similar to the price fetcher, which I mentioned, like an external feeder, which gets the data from off-chain data source and feeds it into on-chain module. And in case the data source is a smart contract, the data feeder would not exist because everything's on that part is on-chain. And in this module, there is no attempt to determine if the data is falsified or malicious. We deal with them in later modules. And this is mainly to tunnel the data through the feeder with some useful security provisions. So as an example, like source authentication is one of the most common ones and is really important, meaning that to establish data integrity, to prove that this data that you're showing is coming from this source that you're claiming. So project like Deco or TLS Notary, they use HTTPS data and use a TLS handshake to prove that this data is coming from the server. Some other projects like Time Crier basically put down the trust in the trusted execution environment, and as an example, Intel SGX. So basically pushing the trust assumptions to this technology and ultimately Intel, the chip manufacturer. And some other aspects that are in the paper. So the next one is selection of data feeders. So from here on, things get tricky. You have to figure out how to define these if you're designing an Oracle. So how would you select legitimate data feeders and weed out less qualified participants? So like early oracles, like Oracle IZ to PriceGet, just use a single data feeder. There were no selection. But we learned that to increase the resilience of the system and availability, we need more data feeders. So one of the first methods would be a centralized allow list selection, meaning that you have a list of legitimate data feeders which you're selecting from. So MakerDAO Oracle version 1 was using this. So the list was approved in a centralized way. And we learned that like by decentralizing the selection process, we can distribute this trust from a single entity to a collective decentral governance. And comparing these two, like central approach has a more optimal speed, but it really depends on the design. So for the decentralized allowed selection, it's possible to do voting, which similarly MakerDAO Oracle version 2 uses voting to add legitimate data feeders to the allow list, but also consider that it introduces the threat that an actor can accumulate voting rights to sway away the vote or even destroy the system. I think it's called gold finger attack. And there are like some incidents like MakerDAO. There was this incident, I think last year, that B protocol team used a flash loan to pass their proposal, which enabled them to be added to the allow list. This is not considered an attack because it was not malicious and the vote was already kind of passed, but you get the point. And the other method is like using staking for the selection, and the mechanics are different than voting, meaning that the data feeders would post collateral against the data that they provide, and it's basically being in dispute phase later on. If they're malicious, they would be punished by losing some of their collateral, which is called slashing. And know that like we also consider reputation-based selections, like Chainlink leaderboard, to be similar to staking, because the loss of reputation will result in reduced income from future jobs. And the main challenge here is what is that in the setting for enough punishment to punishment or slash to thwart malicious actions, like UMA project basically tries to define this as cost of corruption to be higher than profit from corruption, which we discussed it later in this talk, that it's really actually hard to measure that. And additionally, some projects can include randomness on top of all these. Like Teller uses kind of a proof of work style algorithm for each round of data to select 5 feeders, or Band protocol, which uses a random validator from top 100 staked participants. When I was writing this paper, I checked, and Band protocol only had like around 70 staked participants. So it wouldn't be that hard to have 30% chance of being selected as a validator. Just mainly to say that this level of decentralization and the algorithm really requires some network effect to actually kick in and work. And regarding the level of decentralization, also something to consider outside this framework is where are the data feeders getting the data from? So one of the examples that Jeremy, my PhD supervisor, uses is if there's a Nigerian election and we have all Western data feeders in like Canada and United States, probably would you use like Wikipedia to get the data source as a data source. So that is, again, a centralized point in your system. Oh, I forgot to put this on the slides. So we use a framework to basically measure and score some of these different type of selections. So one of the most important parts of the design is also aggregation phase. which mainly means the process of synthesizing the selected data feed into one single output. So just to highlight the importance of this aggregation method, there was this incident for Synthetics, which is a trading platform, that used basically the average of two data points, two data feeders as their aggregation method. And basically the attacker could manipulated one of the two feeders, which inflated the real price by 1000x, and the aggregation averaged them out and still resulted in a loss of a few $1 million of Synthetics because basically it was deviated from the actual price. So there are like different methods, as I said, like statistical measures using mean, median can be used if you believe like your data feeders are feeding a distributed, normally distributed data with possible outliers. Maybe the median can work, but it really depends on the type of data you work with. In order to make that more secure and resistant to market manipulation and the synthetic attack that I mentioned, you could use weighted methods using time, volume, other things. And like as an example, Uniswap V1 only had like a spot price, which you had to do something with to make sure flash loans cannot be used to like change the price and other things. And Uniswap version 2 started adding this whole TWAP or time weighted average price for the price. And now in V3, they added like other things. You could include liquidity volume or some improved TWAP version, TWAP, an optimized way of getting the price, getting the average price. And also you can use random selection, like as I mentioned. You can randomness as some kind of security, but also you have to see what is the set you're working with. The one last thing about like the aggregation phase that you have to consider is what happens if the data is expired or stale. Should it be removed? Should you actually use that stale data or use the old one? We've seen a lot of like designs that they don't check the timestamp or anything, and it's possible that the system that you're designing uses an old Oracle price. So one example is the Black Thursday, May 2020, which the price crashed, the network was really congested with high fees transactions, which resulted in a delay in Oracle price update, in MakerDAO Oracle price update. And given the configuration of MakerDAO auctions, there were like short time frames and some other factors, it resulted in massive liquidation. And another issue was mainly like not having dynamic fees, which we talk in later slides. So the last module that we want to talk about is the dispute phase. So this is mainly to safeguard the quality of final output and give the stakeholders a chance to mitigate the wrong data. I think I'm like really behind my time, so I'm going to go faster here and maybe skip some details. So the first is to distinguish the provider level vetting versus data level vetting, meaning that you could detect and remove bad data providers or vet the data itself. So like as an example, like the provided oriented one could be like a centralized allow list that the provider can be removed, or chain link, which the person could be removed or go lower on the reputation-based leaderboard. On data level vetting, so it's slower because you have to have the data staged and could be disputed. But just to like illustrate what I mean by this is like Teller, when the data is staged for 24 hours before finalization, and if it's disputed, this period could go up to 7 days to actually dispute. Similarly, Augur is using a similar approach. And so after after there is a dispute, you have to figure out how to determine the truth. And you need a correct data as a reference. But of course, if you have the correct data as a reference, why don't you just use that as like Oracle? So there are different approaches, like you can do statistical approach plus the collateral or staking that any feeders would put collateral, and if they're not the honest one, they get like slashed. Also, although consider like a challenge is setting the acceptable threshold for slashing. Like if you have a large threshold, it could moderately incorrect data could go without punishment. If you have a small threshold, the honest data, but honest but faulty or slow data could just, or even volatile markets could be slashed. The next one is like using voting, similarly like Augur or Austria uses. They use voting to vote on the tentative outcome. If it's false, comparing to these two, like a statistical mechanism can be applied automatically, nearly instance, but the voting might take some time for the situation to work out. And one of the last methods is like arbitrage. It's mostly used for the exchange rate between two on-chain tokens. One example is Nest Oracle, which basically data feeders asserts the correct exchange rate between the two tokens by offering the minimum amount of both tokens at the same time. So if the price is not right, someone else can come in or buy ETH, let's say, with the lower price and offer the real price after. So this is really similar to like on-chain exchanges, getting the price from on-chain exchanges, because someone can manipulate the oracle by spending money. That's like a downside. Just to like wrap up the dispute phase. So when you have the correct data, what would you do with incorrect data? So you could either revert or correct, meaning that reversion is this whole data would be annulled and the system would restart and start from the scratch to obtain the data. Correct would try to reflect the new undisputed value. The main difference is the complexity of the dispute resolution, but mainly it impacts the finality of data, meaning that it could introduce delays much longer. One example that was a bit surprising to me was regarding Augur, which is a prediction market on binary events like 0, 1, yes, no. And any observer in the system can just dispute around by staking rep tokens on the other opposite outcome. And when the dispute happens, the window is 24 hours, but it can be extended up to 7 days on disputes. So dispute inception kind of. But it's interesting that if the total stake amount on one issue exceeds 2.5% of the rep token total supply, the whole market, everything about on Augur, enters into a 60-day, 60, settlement phase called the fork window, where all the rep holders should stake on the outcome. And so this is one of the parts that dispute phase it gets tricky, because it could be used to halt your system or even attack correct data, or mainly just to delay finality of data. And one last one, the consequence for data feeders, it could be banned, slashed, and all. So we have like all these implementations in one chart. Please look at this at the table, and if there's anything on the project you're working with or anything that here you seem to be like it's not quite right, let me know. As you may know, projects evolve much fast in this ecosystem, and this table has a limited shelf life of usefulness. However, the whole workflow itself, modules, submodules, and the design decisions are based on the general principle, and they intended to have a long-lasting usefulness. So now we want to enter the dark web. So depending on the Oracle design, you could have like different off-chain data, off-chain components. We shortly talked about this, but it really, if you have like using smart contracts as your data source, you might not have some of these, but you still probably have some off-chain components for monitoring. But as I said, if you're using Uniswap, you don't have anything there. So I'm going to go fast on these because there is not that much time. The off-chain infrastructure usually consists like of a single server, like town crier, or sometimes many nodes that intercommunicate through a consensus protocol like Chainlink OCR. The main important parts about these is like availability and the DOS, or dynamic of system, denial of system service resistance. Connection to the data source, you could use the source authentication to prevent some of the attacks. Data feeder network, like OCR, Chainlink OCR uses this leader that gathers all the signatures, and when the consensus is achieved on the aggregated data, it just sends the data with the signature to the blockchain. So it reduces the cost significantly while maintaining similar security because of the digital signatures. But as I said, availability is really critical here. MakerDAO Oracle V2 uses a similar off-chain network of feeder network, and in December 2020, they had a few hours outage due to a bug on their peer-to-peer data feeder network stack, and the system could not work. So there is so much literature on the peer-to-peer network, like Sybil attacks and Kona attacks, that we point out in the paper. And the last one here is like the transaction creation, which is another important aspect here. Like that you need to keep this private key secure and the signing process secure, because if anyone can compromise this, they can impersonate the Oracle, which is a big deal here. And positive balance for gas or dynamic gas fees, which like an example is in September 2020, 9 Chainlink operators were attacked through the spam attack, and they lost around 700 ETH in gas fees. So it's really important to like keep the monitoring of the network state and make sure the fees are set. And again, availability here is the main key. The blockchain infrastructure, I won't get into that much detail here right now, but you need the blockchain node synced and available. Possible that there would be network partitioning attacks or other kind of attacks. The block creation, we have front-running, possibility of front-running attacks, or if miner, I would say transaction reordering when the miner reorders that, or MEV, or maximum extraction of value when, or maximum extractable value when it's on the flashbots or similar to that. And the last one is in the consensus level, actually it's not last, which the uncle blocks could be used, or small reorgs could be used to attack your Oracle. Meaning, like one example is the Ether roll reorg attack, which Ether roll is this on-chain gambling game where users bet by sending a number and wait for the Oracle random number to have a specific condition. In April 2020, the Ether team detected that there is like this front-running attack on their platform, and it was a really interesting attack that the attacker was betting constantly and just waiting for small forks or some uncle blocks coming in. And in those uncle blocks, the original bet was there also the Oracle random number response, and because of the reorg, they would just go back to the mempool, and the attacker would just replace its own original bet with a winning bet and with high gas fee to just front run its original bet and basically win the round. There is like extensive research on consensus mechanism and how to attack them that we won't just discuss here. So we have two different kind of designs, like an end in itself design, which is like a smart contract designed to be an oracle, and a means to an end, which is an oracle that is byproduct of an oracle, another application. I'm just gonna go faster here. So the interaction models, we have like a feed which publishes data for others to see. There is no additional transaction needed, although there is an interval to update. We have request and response, which is really similar to client-server API request, and at least 2 transactions are needed to get there. We have this other possible design, it's called subscribe and response, which is similar to request and response, but doesn't need to have a transaction to request. It could be off-chain agreement or oracles can subscribe to the event and these kind of things. So Oracle smart contract, which can include the data feeder selection, aggregation mechanism, dispute resolution. Also, if it's a feed, a data feed storage, authenticate, or also authenticate Oracle response. This is really important because I've seen some projects, even once it was seen that I think it was, I forgot what project it was, Nexus Mutual, that on their code, gladly it was not attacked, but they were not checking the callback that is coming from actual Oracle. And anyone could just call that function and update the values. So yeah, I'm just like passing by these because I see that I'm not going over time. So the main points here, I know it was too fast at the end, sorry about that. The main points here is like there are some learnings from this whole research. And one is like the oracles use their governance token for staking a lot of times. And there are two necessary conditions here. One, the market capitalization of the token should stay material. The token should be evenly distributed. And I know Vitalik has this blog that talked about this system, like using Uni as such a token. Also, Gitcoin could be used, and now maybe Fox even. But consider that like a collapse in the value of this governance token threatens the entire system. So consider that. And we need a way to like be able to incentivize on-chain oracles for use cases with no direct revenue. Like if you need weather data on-chain, how would we be able to incentivize users for that? Because there's no direct income from the value from the trades or anything. And the third is diversity in software promotes resilience in the system. So if there's one project that everyone relies on, failure in that project have like cascading failure across DeFi and the whole ecosystem. We should consider that. And the last one, which I wanted to get more into more details, but there is no time, is you can't capture the full extent of profit from corruption because that profit could be outside Ethereum, outside all the places that you're looking into. And so, yeah, I would be happy to like continue any of these discussions over Twitter, or feel free to email me. And with that, I conclude my presentation and open for questions. Yeah. And I would be happy to answer on Twitter and email, anything there. So. Thank you. Thank you. Hopefully see you there next year.